Hi class. I'm going to try to show you how to solve an important problem in chapter 6 that I demonstrated before, but in the opposite direction. The more typical example asks you, like, what's the probability that x is below 90? What's the probability x is some other range of numbers? But now we're asking in part 6.2.5, part D as in David, um, we're looking for 99% of between two x values. So let's begin that. One way of doing that is by um, an important thing I believe in is to illustrate the problem, make an illustration to help you visualize it. Let's see a full screen. And let's begin by drawing the bell-shaped curve. First I have to do this. Let's begin by drawing the bell-shaped curve, which has, of course, a middle value, in this case, of 100, and a sigma, or a spread, of 10. And we're looking for that x value and its opposite on the other side of the mean uh, that that has the property that between them is contained 99% of the total area, which means this little piece that, let's deal with this x first. Might be a drop easier. This little piece here is the missing 1% divided by 2. So it's 1 minus 99 is the missing pieces on the outside. And since there were 2 of them, we divided by 2. So it's 0.05, which you can do on a calculator or in your head. So this piece here is literally contains 0.05% of the area. So the question is which z value, because we have to find the z value before we can get the x value, will satisfy that relationship. So going back to the course compass uh, negative z table, we see that 0.05 is found 0.05. I should note this better. 0.055, 0.005. It's in between 0.051 and 0.049. Let's make it 2.58. I think 2.5 meets 8. That's a good enough approximation. So negative 2.58. Go back to the smartboard. So this value, this is the z value that corresponds to this. Z is equal to, back to, z is equal to negative 2.58. But we know the relationship between z and the x is x minus the mu over the sigma is equal to the z, which in this case is negative 2.58. And the x in this case is unknown. The mu is 100. The sigma is 10. By cross multiplying the 10 divided minus 2.58, we end up with a new relationship. X minus 100 equals 25.8, or bringing the 100 to the other side of the equation ends up with x equals to 25.8 plus 100. I'm sorry, this is minus 25.8, so it's 100 minus 25 is 75, minus the 0.8 is 74.2. It's 74.2. So the x in this case, by the way, this is really incorrect. It's not. The x here is 74.2, which makes sense because if you look at it visually, we have 100 as the middle value. You go across one standard deviation, you're at 90. Another standard deviation, you're at 80, and it's a little bit below 80, so 74.2 seems to be the answer to the bottom value of the two values. What about the higher value? Well, the higher value satisfies the relationship that the z value below this point is the 99% plus the other 0.005. So it's 99.995, which is 99 plus a half a percent. If you look that up on the z table, let's go back to the course compass and the positive z table. 0.995 is right here at by symmetry positive 2.58, right here. And again, you can move it up to see that it's at 0.08. So we can we can um, we can put down that 2.58 that 2.58 equals z, which is x minus mu over sigma. And x in this case is the unknown, mu is 100, sigma is 10, or if you solve this equation, you get x equals 25.8 plus 100, or 125.8. And again, visually it makes sense. It's about 110, 120, 125.8. So the 125.8 is the answer to the question. Let's go back to the course compass and see if we're right. Um, the answer is 74.8, 74.8, two decimal places make it 80, and 125, 125 point, what do we say it was? 125.80. I'm sorry, 74.20, 75.20, 125.80, and check answer. Excellent. Thank you, Course Compass, for giving me that positive feedback. All right, so turns out there's another way to solve the problem, um, which is to use, as I told you in some of the mailings, something called a online calculator. This is available for most of our examples. You can use Excel, you can use the StatCrunch, but I typed to Google normal distribution calculator. This is what popped up first. Now, in this case, we went to probability below which particular mean 100. The standard deviation we're told is 10, and you want the cumulative probability to be 0.995. This is best done by the diagram. So what's the value for the x? Let's calculate. And what pops up is 125.758 or 1.25.8. So using the calculator, which again you can find on your own, solves that problem. Let's shut down this